यसलाई घुमाएर गर्नु न घुमाएर कतिखेर आएको त अच्छा पुरै गरा पासपोर्ट भेजे ऐसे नहीं चलेगा तो नहीं वो हो रहा है। पासपोर्ट कॉपी स्कैन किए वो ना। हाँ, तेरा हो गया ये। वो क्लियर भी नहीं है। साइड में आया हूँ मैं। आपको पासपोर्ट भेजते वैसे स्कैन करिए। फर्स्ट पे चाहिए खाली हमको। ओके मैं भेजते आपको सिंपल के लिए। हाँ आपको पासपोर्ट ओके ओके।
Okay, using Django systems here. Understood? Slowly,
Okay.
slowly you will understand how to do the rest of the things. So what I've done here is, let me go to my Anaconda. Uh, but before that one, so this is the data set. Hope all of you can see the data set here. Okay, so this is the pregnancy time. Okay, so sometimes what happens that during the pregnancy time there may be chances of having diabetes. I think you are familiar with this, right? Hello.
Yes, sir. Yes, sir.
Yeah, during the president, humans will face this problem. Okay, diabetes during diabetes. Sorry, during pregnancy time, they'll have the chances of diabetes also. So our job is to predict the diabetes during the pregnancy time. Understood? So this is the data set, and these are the features. Pregnancies. Okay, when it comes to pregnancies, number of children, I guess. Glucose contents, blood pressure, skin thickness. Okay, insulin, BMI stands for body mass index. That is nothing but the weight of the body. Okay, diabetes, pressure. Okay, so all this data you will get from the lab. Even the age also. Okay, age, and this is going to be my target function. Whether the client is having suffering from diabetes or not. One means yes, zero means no. Understood? So hope you are clear with this. This is a very clean data, and I have around 700 records, I guess. 700 plus records I have, 760 records I have. Clean data. Okay, you can download directly from Kaggle, or if you want, I can provide this the data set. Understood? So I don't want to focus more on this area. Okay, instead of focusing more on how to deploy the machine learning model. Okay, hold on. Yeah. Okay, so instead of focusing more on how to deploy the model. Okay, so shall we start, participants?
Yes, sir.
Hello.
Yes, sir.
Okay then. So let me try to quickly. I'll try to explain this the program. This is the same thing how we did in the last previous sessions. Okay, same thing I'm following here also. Along with this, okay, so I'm going to use two more library called Pickle and Joblib. Most important is Joblib. If you want to convert your machine learning model to machine learning programs to model, okay, so you use Joblib. Okay, so rest of the things are same. Pandas, matplotlib, numpy. Understood? So let me run this quickly. I'll try to execute this. Next, I'm loading that CSV file, diabetes file. Understood? So next, you know this. Okay, read underscore CSV diabetes. The next is data head. Okay, to display the 5 records. But in this case, have a look on this. So some of the records, if you check here, skin thickness, insulin. Okay, having zero, right? Yes or no? Hello?
Yes,
Okay.
sir.
These are having zeros. So that means it should not be a zero. So I need to replace this one by mean value. Okay. So that we are going to do here. So, but before that one, let's try to take the try to check the shape. Data dot shape. There are 768 records, 9 features are available. Okay, data is null. If you want to check whether the data null values are available or not, okay, you can use this data is null dot value dot any. Understood? False. There is no null value. If you want to check the sum individual by feature wise, so you can run this code. Data dot is null dot sem. Understood? Since I have this many features here, okay, so all the features are uh, I have the clean data. Okay, there is no nil data here. Understood? Hope you are clear with this. Any doubt, participants?
Clear, sir.
So now next most important thing is checking whether the data is balanced or imbalanced data. Understood? So since if you can run this outcome is my target function dot okay value underscore counts you type. Okay, so value underscore count. Okay, try to segregate the data, classify the data in terms of 0 and 1. So as far as 0 is concerned, I have 500 records. 1 is concerned, I have 268 records. So in the ratio 1 is to 2, I have the data here. Understood? So I can say that nearly 60% I have one data, two data, and 40% I have the false data. Understood? We can go with this data. We can design the model, but I recommend you to perform a smart operation. Smart in the sense, okay, try to equalize the data. So that means I have 0, 500 and 268 record related to 1. Understood. Now next, let's try to correlate the data. Correlation. Okay, the relationship between the features here. Have a look on this. So what I have done here is Seaborn I'm using, matplotlib. Okay, so this is the method if you want to check the correlation between the data here. Understood? Data dot correlation. Since my data is stored in the variable called data here. So this is how we are converting into pictorial representation or visualization. Have a look on this data. If you check this data, run this one. Okay, run this code. If you check this data, hold on, it's executed. Any doubt, participants? I don't want to repeat. Okay, same thing. Yeah, same. I'll share this file. Okay, don't worry. The main intention is to teach you how to deploy the model. So have a look on this. If you check here, pregnancy, okay, pregnancy with other features. Let's say pregnancy with, have a look on this. Somewhere 35. Have a look on this. Age. Can you see this? Right?
Yes, sir. Yes, sir.
Age. That means age factors a lot here. They are 50%. If I can expect more accuracy if I have more age data here. And age also factors a lot. Okay, when the number of the age is how the age of the woman is increasing, the chances of diabetes during the pregnancy time also increases here. Hope you are clear. You can see, okay, clearly, okay, I can analyze here from the correlation or this visualization graph, okay, nearly 54%, okay, so age factors when it comes to diabetes. Okay, so next in the same way, glucose, have a look on the glucose. Glucose with respect to other features like 26% age, but okay, so in the same way, glucose. Okay, so as far as glucose is concerned, 33% insulin. Have a look on this. Insulin. Okay, so insulin factors a lot here. So that means we can predict more accuracy in this. Glucose with respect to insulin. Understand? They are dependent on each other. Okay, so it's similarly correlation we can have a more college correlation here. But if you check